Welcome to the Explainer. You know when you ask a search engine a question and it just clucks the perfect answer right out of a huge article? It feels kind of like magic, right? Well, today we're going to pull back the curtain and see exactly how that trick works, how an AI can read a document and find the exact answer you're looking for. Okay, let's just dive right in and see this in action. We're going to ask our AI model a question about a document it's been given. The question is pretty straightforward. Who was Bernadette Subaru's? And boom, just like that, the model instantly scans the text and highlights the answer. It's incredibly fast and it's spot on. But this isn't magic. It's a very specific kind of AI at work. So how does it actually do that? Well, this little magic trick has a name. It's called extractive question answering. And the concept behind it is actually way more intuitive than you might think. Think of it like this. The AI is basically a super fast student with a highlighter. It's not writing a new summary, it's not getting creative, nope. It just finds the exact phrase, that direct span of text that already exists in the document and pulls it out for you. And this brings up a really key distinction. Our highlighter model, the extractive one, is perfect for fact-based questions like, who invented this? But if you ask something more open-ended like, why is the sky blue, you'd need a totally different approach. That's a generative model, one that acts more like a summarizer, creating a brand new answer from scratch. So, how do you teach a machine to become this expert text detective? You can't just throw a library of books at it and hope for the best. It actually takes a really carefully structured training plan. The whole training process really just comes down to 3 basic steps. First, you got to give it a good textbook. Second, you have to translate that textbook into a language the machine can actually understand. And third, you give it an answer key so it can check its work and learn as it goes.
Now, that first step, the textbook, is absolutely crucial. For this kind of task, a lot of models use a famous dataset called Squad. Just imagine a massive collection of Wikipedia articles, but with a special twist. For every article, you also get a bunch of questions that real people asked about it. And here's the most important part, the exact location of the answer is already marked out.
Okay, on to step 2. Here's a key thing to remember. The model doesn't read words like you and I do. It's a machine. It speaks one language, and that language is math. So we have to translate all of our words into something it understands, numbers. And this whole translation process is called tokenization. Every word, or even just a piece of a word, gets turned into a unique number or an ID. But to help the model make sense of it all, we also add these special tags. Think of them like punctuation for the AI. The CLS token at the beginning basically says, hey, start reading here. And the SEP token acts like a hard wall, telling the model, okay, the question ends here, and now the main text begins. And this, right here, is the absolute heart of the whole thing. The model isn't learning what Bernadette means. Its entire job, its only goal, is to look at this long string of numbers and predict just 2 things: the number or the address where the answer starts and the address where it ends. That's it. It's just a location-finding game. Okay, so this system is great, but there's a big problem. These models, like BERT, have a really strict limit on how much text they can read at once. So, what happens when you have a super long, dense Wikipedia article? The model can't just read the whole thing.
And the solution is actually super clever. It's a technique called a sliding window. Instead of trying to feed the model the whole document at once, which it can't handle, we just break it down into smaller, manageable chunks that slightly overlap with each other.
So first, the model takes a look at the very first chunk of the document. It scans it, looks for the answer, but nope, it's not in there.
No problem. The window just slides over a little bit, and now the model looks at the next overlapping chunk. It tries again.
And it keeps on sliding, chunk after chunk, until finally it hits a chunk that has our answer. But wait, think about this for a second. The model also just learned from all those other chunks where the answer wasn't. And that's incredibly valuable, because that's how it learns the crucial skill of knowing when to say, you know what, the answer just isn't in this piece of text. All right, so the training is done, but we're not quite finished. The model doesn't spit out a nice clean sentence. It spits out a ton of raw scores. So we need one final step to turn those numbers into something a human can actually read, and of course, to see if it did a good job. This is kind of the final cleanup phase. For every single token in the text, the model gives us 2 scores. How likely am I to be the start of the answer? And how likely am I to be the end? Our job is to find the start and end pair that has the best combined score. And of course, we throw out any crazy answers, like one where the end comes before the start. That makes no sense.
Then we take the best valid pair and convert those numbers back into real words.
But the million-dollar question is, did it actually work? Is our model any good? Well, to find out, we grade it. We basically give it a final exam, running it on the squad test data and comparing its predictions to the real answers to see how well it stacks up.
And the final score is 88.5, which is fantastic. That tells us our model is performing right on par with the original benchmarks set by the researchers who created these things. So yeah, it officially passed its final exam, a success.
Now, I know some of this can feel a little academic, a little bit in the weeds, but here's why it all matters. This exact technology isn't just sitting in a research lab somewhere. You are already using it every single day. You know that little answer box that pops up at the top of your Google search? That's this. That customer service chatbot that actually finds the one sentence you need in a giant help manual? This again. And for people in fields like law or medicine who need to find one critical piece of information in mountains of documents, this technology is a complete game changer.
And that really leaves us with one last big idea to think about. As these AI systems get better and better at finding any answer that is already written down somewhere, what does that mean for us? Maybe, just maybe, the most important human skill is no longer about having all the answers, but about learning how to ask the right questions.